Hi, I've recently made a series of boxes to house my tools. Sander, plunge saw and large circular saw that I have. The boxes are really easy to make and very cheap to make too. I think these cost under $15 per box roughly. They're made of plywood, not particularly fancy, just use a piano hinge at the back which fully opens up so you can install your tool or whatever you need to inside. I need to make another box because I have bought a new grinder. So I'd like to put that in its own box with all of its accessories. So if you want to see how it's made, follow along and we'll make a box. So these are the components that make up the Systainer box. In total there are 8 parts. There's a back, a top and a bottom, 2 sides, and the front's made up of 3 components. So the 3 components, and this is essentially just for aesthetics, but it matches the sort of Systainer look. So these just go together, these will get glued together and form the front piece. So something like that when it's finally all glued up. To put it all together, we will just use a bit of glue, and it's all just butt jointed, and just to give it a little bit more rigidity I'm using some 6mm dowels as well across the tops and bottoms, just to tie everything together nice and solidly. One thing that I found really helpful when making this Systainer was, because I've made it out of had to cut down a sheet, was figuring out how to best cut down that sheet to get all the components out that I need with minimal amount of wastage. And I found, and I'll take you through a quick run through it now, some software called Cut List Optimizer. So this is a program called Cut List Optimizer. So if you type that into Google, it should pop up and you'll get a link to the program. It's all done online, so you don't get to save this to your computer, but you do get to save it to the cloud, I guess, is where it goes. But and the advantage of that is that if you've got other devices, an iPad or an iPhone, and you're working in other areas, you can quickly look up this information with another device just by logging in online. It doesn't cost you anything. As a casual user, I think you're allowed to do 5 or so plans a day without any cost. So for a DIYer, I find that's really adequate. But essentially, over on this side is the panels that you need to cut. So these are all the panels that we cut. And then down here is the sheet stock. So in this case I was cutting it down from a 1200mm by 600mm sheet, and here's a picture. When you do the calculation, it then figures out and gives you a picture of how all of these cuts need to go. And what's really useful is down here is an illustration of which cuts you should make first. This sort of breaks it down into a convenient approach to how to best and minimise the number of cuts that you need. So I just find it really clever, the way that it works and how quickly it works. It's definitely the best one that I've seen, and I just find it's really cool for if you've designed something up and you're just trying to fit it to a sheet. I've tried a few different ways of working out how to best utilise a sheet with parts when I'm making projects. And in theory it seems simple enough, but when you come to try and do it, you realise there's lots of combinations. And I believe in this program, this runs through about 1 million computations to figure out the best way of aligning these components to the sheet that you've got. That's something that would take me a much longer time than a computer to figure out. It also has, a few interesting things here. It can take into account the kerf, thickness of your of the blade, and whether you've got edge banding, or you need to take in consideration the grain of the wood that you're cutting. Most of these things I haven't used before, so I couldn't tell you exactly how to use them, but they're things that are there, so one day if I do cut down anything other than MDF or plywood, then this might be useful options to consider. But anyway, if you get an opportunity, check this out. It's free, and I found this super useful. So for the assembly, we're going to need some clamps and some corner brackets, a few here that I made up, and some glue. Okay, now with this centre bit just drying in place, we can start to put the dowel pins in. So wherever we've got the butt joint, I'm going to put some dowel pins, so across the bottom and across these two sides to pin everything together, and then we'll do the same when we put the top on as well. Okay, so now pretty much the box is complete, and we're ready for the next stage. We've put in all the dowels, glued it all, and we've got a box. But what we need to do now is create a lid, and to do that we'll cut on the table saw the top probably about 30 or 40 millimeters down from the top here across like that and all the way around, and then it'll make a top which will then put some hinges across the back, and I'll show you that when we get to that spot. But before we get to that, we need to do a bit further clean up, and what I was going to do is just route these sections here. You can see that there's a profile here now, and I want to just follow the router down through that using an edge trimmer to knock that bit out to make it look a bit better. And then also what I want to do is create a couple of holes in here as handles, just to act as handles so I can pick up the box a bit easier when it's on the shelf.